All right, folks. So we're going to take a look at some extra practice problems on finding the first and the second derivative for for parametric equations. Okay. So let's take a look at question number 1. So question number 1 says x equals t to the fourth minus 1 and y equals t minus t squared. And so if we're trying to find the first derivative, then I think that's something that we feel mostly comfortable with, that we have dy dx equals dy dt over dx dt. And when we are finding our derivatives at the end, we'll get 1 minus 2t for dy dt, and we will get 4t cubed for dx dt. Now, there's nothing wrong with leaving it like this, okay? If all you need to do is find the first derivative, I would 100% leave it here. But since we know we're going to be finding a second derivative, I'm going to encourage us to simplify what we have, because we're going to need to take a derivative of this again, okay? And so in this case, I would say a nice way to simplify this is break it up into two fractions. So we get 1 over 4t cubed minus 2t over 4t cubed. And then I'm going to simplify this even more so that I write my powers as negative powers and I reduce what I can. And so that will give me 1/4 t to the negative 3 minus 1/2 t squared, or t to the negative 2, I'm sorry, okay? So first derivative, not so much a problem. Second derivative, let's write our formula, and then let's color code where we put the different things, okay? So for the second derivative, I'm going to have to find the first derivative of my answer from above. I'm going to take the derivative of my answer from part A. And I'm going to divide that by dx dt. Okay, so this is the setup that we want. So let's color code. What are we putting where? My dx dt, as I found from my first derivative, is 4t cubed. That means on the bottom of this fraction down here, to find my second derivative, I need to write 4t cubed. So let's go ahead and do that. 4t cubed. Okay, now this was a part that a lot of folks were missing when we were doing the quiz, so I just wanted to point that part out, okay? The second part is for the numerator. We need to actually find, we don't just take our answer from part A and put it here. We need to find the derivative of our answer from part A. Okay, so I need to take my answer from part A, often easier if you simplify it a little bit, and find the derivative that's going to be my new numerator. Okay, so let's take our derivatives. This will give me negative 3 over 4 t to the negative 4 minus negative 2 over 2 t to the negative 3 all over 4 t cubed. Okay. I do want to clean this up a little bit. Let's write it with positive exponents, not negative exponents, and we can reduce that 2 over 2. So my denominator is still 4t cubed, but on the top I have negative 3 over 4t to the 4th plus 1 over t to the 3rd. Now, I think a lot of folks got caught up on the quiz in terms of simplifying, and maybe that's due to the resources that you use to help you figure out this problem. But I'm actually less concerned about the simplifying. You are more than welcome to leave your answer like this. That is totally fine, okay? The process I'm looking for is find that first derivative, find the second one, but know where all the pieces go, okay? So again, we have our dx dt on the bottom, and on the top is not our dy dx, it's the derivative of our answer from part 1. So this is derivative of our answer from part A, okay? So don't forget to take the derivative. Don't forget to use whatever rules you need to use to find that derivative. And then don't worry so much about the simplifying, worry more about the calculus, okay? All right, so that was example 1. Let's take a look at example number 2. All right, so in example number 2, we've got x equals sine pi t and y equals cosine pi t. And so let's go ahead and find our first derivative, dy dx. So I'm going to find dy dt, and I'm going to divide that by dx dt. All right, dy dt will give me negative pi sine pi t. Got to use the chain rule. And then I divide by the derivative of x, which is going to give me pi cosine pi t. Now, if I only wanted to find the first derivative, I could stop here. Since I know I want to find a second derivative, I'm going to simplify here. Those pi's cancel out, and I get negative sine pi t over cosine pi t, which is reducible to negative tangent pi t. Now, why would I take it all the way down to tangent? Simple answer, if I leave it like this, I'm going to need quotient rule. I don't really want to do quotient rule. If I reduce it to tangent, I just need to use chain rule. Okay, so that's my reasoning behind simplifying as far as I did. Okay, so let's do our color coding so we know what's coming up. I know that dx dt is, and I have to take the whole thing, not the simplified one, but the entire thing, pi cosine pi t. That denominator is going to be the same as the denominator for my second derivative. To find my derivative of my answer, I don't have to use the whole thing here. I can go straight to this part at the end, and that's what I'm going to take the derivative of to get the numerator of my second derivative. Okay, so we have the derivative of dy dx, and I'm going to divide that by dx dt. That means I need the derivative of negative tangent pi t. And I need to take my denominator unsimplified from part A. So the derivative of negative tangent pi t divided by pi cosine pi. All right. The derivative of tangent is secant squared. So I have negative pi secant squared pi t divided by pi cosine pi t. Now, since I'm not finding a third derivative, I could leave it here, but I think this case it's probably just as straightforward to reduce those pi's away to a 1. And because 1 over cosine is secant, I might even go as far to say this is negative secant cubed pi t. Okay. So there's our second derivative. I, again, am less concerned that you get to the answer in the box and more concerned that this intermediate setup part is accurate. Okay, so don't worry so much about the simplifying after. Worry more that you're plugging in the right values in the right places. All right, let's take a look at example 3. So we have x equals e to the negative t and y equals t e to the 2t. Now, as soon as I read that second part, automatically I'm thinking I'm going to need product rule if I'm taking my derivative, which I need to. So let's set that up. U equals t, du equals 1. V equals e to the t, 2t, excuse me. And dv equals 2 that gives me 2e to the 2t. Okay. So, as a reminder, product rule is u dv plus v du. Okay. So, let's plug those in for my first derivative. My first derivative is going to be dy dt over dx dt. So dy dt is going to give me 2t e to the 2t, that's u dv, plus v du is e to the 2t, and then I divide that by the derivative of x, which is negative e to the negative t. If all you're doing is finding that first derivative, leave it like this, okay? But if you plan to find a second derivative, which we do, let's simplify. I can factor out an e to the 2t. That'll leave me with 2t plus 1 divided by negative e to the negative t. I can bump that e to the negative t up to the numerator, and I get negative e to the 3t, 2t plus 1. Okay, so I found my first derivative, and I've simplified it because I know I want to find a second derivative. Okay, so let's write out the formula for the second derivative. I'm going to need to find the derivative of my answer from part A. Then I need to divide that by my denominator from part A unsimplified. So my denominator is going to be negative e to the negative t. That's going to replace my dx dt. And then if I'm thinking ahead, if I want to find the derivative of my answer, this whole thing right here, I want to already think, hey, you better use product rule. Otherwise, you're going to get the wrong derivative, okay? So I'm already thinking ahead what I'm doing rather than plugging in things and just kind of hoping it works out, okay? So take some time to think, plan out your strategy of attack, and think, make it very obvious to yourself what you're going to need so you don't miss something silly like the product rule, okay? So let's set up our product rule in this box. U equals negative e to the 3t, du equals negative 3e to the 3t, v equals 2t plus 1, and dv equals 2. So that's what I'm going to plug into my product rule for the numerator of my second derivative. All right, so u dv is negative 2e to the 3t plus v du is going to be negative 3e to the 3t times 2t plus 1. That's my product rule. That's the derivative of my answer from part 1. Now I just need to copy my denominator from part A, negative e to the negative t. All right. And since I'm not finding a third derivative, I'm just gonna leave my answer like this, okay? Done. All right, let's try one last example here. We're gonna take a look at example number 4. So we have x equals t to the 1/2, or the square root of t, and we've got y equals 2t plus 4. So if I want to find my derivative, I need to find dy dt, and I need to divide it by dx dt. Dy dt is pretty easy here. It's just going to give you 2. And I might rewrite x as x equals t to the 1/2 so that I can prepare myself to take the derivative using power rule, okay? So the derivative of t to the 1/2 is 1/2 t to the negative 1/2. Now, if all I'm doing is taking the first derivative, I would just leave it, okay? But since I'm going to be taking a second derivative, let's simplify this. So I have 2 divided by 1/2 square root of t, which is the same as 2 times the reciprocal, which is 2 root t. And that gives me 4 root t, or since I know I'm going to be taking a derivative, 4 t to the 1/2. Okay? Now, before we leave here, what is the best denominator to move to the bottom of the second derivative? I'm going to go ahead and pick this one because it's not simplified in the sense that I combined it with the numerator. It's just rewriting 1/2 t to the negative 1/2 into a friendlier format. And what am I going to take a derivative of to find the numerator? I'm going to take a derivative of 4t to the 1/2 to find my numerator for the second derivative. So here we go. d dt of dy dx over dx dt. My numerator is going to be the derivative of 4t to the 1/2, which is 4 times 1/2 t to the negative 1/2. And my denominator is 1/2 root t. Okay, so let's reduce some things. 4 and 2 give me 2. Let's rewrite my numerator as 2 over root t. My denominator is 1/2 root t. And now we'll keep the top fraction. We'll multiply it by the reciprocal of the bottom fraction. And my root t's cancel out. And all I'm left with is 2 times 2, which gives me 4. Okay. So I know these examples were maybe a little bit more straightforward than the quiz, but the concept remains the same. That what we're going to do is that denominator from our first derivative stays as the denominator for the second derivative. But it's the derivative of our answer from part A that gives us the numerator, okay? So I hope that was helpful. Please let me know if you have any other questions on that, and I will try my best to answer that and clarify that for you. All right, thanks so much, folks. Have a great day.